This is Brian from enginenerds.org, delivering knowledge in behalf of Chemical Engineering Philippines. Today, we are going to present the 10 most important equations in history. Before we proceed, let me get this straight. We know that there are lots of remarkable equations that has been formulated throughout the ages. This blog doesn't mean to belittle those achievements but rather to highlight those which has been outstanding in the fields of engineering, mathematics and sciences. These 10 equations helped shape our modern world. Without them, things might look very different indeed. Please note that this list is far from exhaustive and is in no particular order. First in our list is the Pythagorean theorem. The essential relationship between the two legs of a right triangle and its hypotenuse is named for the Greek philosopher Pythagoras. A staple of school mathematics lessons, this equation is one that actually changed the world. It enabled us to be able to formulate better maps and help find the shortest distance between things, amongst other things. It is also used heavily in architecture, woodworking, and many other fields. The insight brought together the disciplines of geometry and algebra, and it's a good early example of using the relationships between shapes to derive a basic observation about numbers. Next in our list is none other than calculus. Calculus, originally called infinitesimal calculus or the calculus of infinitesimals, is the mathematical study of continuous change, in the same way that geometry is the study of shape and algebra is the study of generalizations of arithmetic operations. It was developed independently by the great Isaac Newton and Sir Gottfried Leibniz. After its invention, it joined algebra and geometry as one of the pillars of mathematics. Another important type of equation that worth noting is the logarithm. Logarithms are another type of equation that changed the world. They helped us make tedious calculations before calculators existed. A logarithm is a quantity representing the power to which a fixed number, also called the base, must be raised to produce a given number. Using logarithm tables allowed the elimination of many tedious steps in calculations in fields such as surveying, navigation, and engineering. Is there other equation that is more famous than Einstein's equation in relativity? It is very well known as E is equal to mc squared. Einstein's famous equations on relativity not only answered many previously unsolved questions, but it also helped change the way we look at time, space, and gravity. It is used to assist in explaining everything from black holes to the Big Bang, to nuclear power, and also GPS on our phones. Next in our list is popular especially in statistical analysis, and we call it the normal distribution. We are all familiar with bell curve graphs today. They help to describe the distribution of data in a given set. It can be used for anything from IQs within a population to the results of an exam amongst a group of students. Within a normal distribution, most data points will fall somewhere in the middle, with fewer individuals towards each extreme. And now we have the Schrödinger's equation. Schrödinger's equation is essential for modern computer chips and lasers. It also helps keep cats in a form of suspended animation between life and death, apparently. But seriously, this equation literally changed the field of quantum physics forever. It is a linear partial differential equation that describes the wave function of a quantum mechanical system. Its discovery was a significant landmark in the development of quantum mechanics. For the physics enthusiasts out there, we will now be talking about Newton's law of gravitation. Newton's law of universal gravitation states that every particle attracts every other particle in the universe with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Newton's law of gravity is one of the most fundamental equations in physics. Next we have the wave equation. The wave equation describes the behavior of waves, which seems like a vibrating guitar string, ripples in a pond after a stone is thrown, or light coming out of an incandescent bulb. The wave equation was an early differential equation, and the techniques developed to solve the equation opened the door to understanding other differential equations as well. It effectively forms an essential component of electromagnetism, optics, fluid dynamics, and heat transfer. The second law of thermodynamics. This states that, in a closed system, entropy is always steady or increasing. Thermodynamic entropy is, roughly speaking, a measure of how disordered a system is. A system that starts out in an ordered, uneven state, say, a hot region next to a cold region, will always tend to even out, with heat flowing from the hot area to the cold area until evenly distributed. It helps us, among other things, to understand the direction of heat transfer. This theory can be expressed in terms of the change in entropy of a system. In this equation, the change in entropy is calculated by measuring how much heat has entered a closed system divided by the common temperature at the point where the heat transfer took place. Last but definitely not the least in our list is the Fourier's transform. THS equation is basically at the heart of modern signal processing. It is also essential for signal analysis and data compression. The Fourier transform is essential to understanding more complex wave structures, like human speech. Given a complicated, messy wave function like a recording of a person talking, the Fourier transform allows us to break the messy function into a combination of a number of simple waves, greatly simplifying analysis. We hope you enjoyed our brief chat about these wonderful equations that definitely changed the way we live in today. Thank you for your continuous support to Engine Nerds and Chemical Engineering Philippines.